So not an assignment, an example. We're going to output a file that was produced in the SolidWorks class. Has some interesting shapes and geometry. And you're going to encounter these translated files at some point. So since I'm going to provide for the for that midterm sheet metal piece a DWG, this will be the same process as what you're going to work through for it. So the originating document, SolidWorks, whether it's SolidWorks, ProE, NX, Solid Edge, Inventor, go down the list, somehow they're going to put it out as some kind of translation. If they're in their drawing module, it's probably going to be a DWG. So save as, and I need to find a place to put this, so let's put it into, actually I just wanted to back up one, 236, and I'm going to save as type, and DWG or DXF. So the exchange format versus a drawing, it's kind of a toss-up anymore. It's not as critical. Some of the machines that would import directly would only bring in a DXF because it didn't have as much of the header information, the program information embedded into it. All right, so under options then, I would be concerned that if it didn't load, that I found a version old enough that whatever version I was running of Mastercam would be able to accept whatever version of DWG. Most of the time, they're pretty close to current. And just out of habit, I will make it old enough that it doesn't matter. So in this case, I've gone to an extreme 2000, 2002. No, I don't want to reset anything. 2000, 2002 will pretty much cover the gamut of everything that I want to import. All right, so I'm going to go ahead and
say. Pretty low common denominator.
Right. Okay. You know, it's you know, somewhere in the last 15 years it should be able to import this file. Mm-hmm. The other side of this, then, I will just since we're talking about the translations, if it's a solid, you may get a solid file, which not entirely sure that Mastercam is still working under the solids module. You may have to have an additional package to import a solid and work directly on it. Education version, I don't think has that limitation, but in industry, if you tried to bring in a parasolid binary, what's the other one? IGES. Okay, it's in there somewhere. IGES and step files. Those all come in as solid imported geometry, and you can work directly on those if you have the correct license level. All right, so depends on what you're given and what to ask for based on your program and what you're working from. So we found that this is a merge, and our import then is. Let's see if I can remember where I saved it. And we're going to tell it to bring in AutoCAD files. So there is my information. Interesting. It wants to bring in layout to import. That's not, I should see sheet 1. All right, so sheet 1 came in. That was the important one. And scale is 1/2. So by all rights, I should. Well, I'm not sure. Oh, good, nice tooltip. Scales the pattern entities, type a numeric scale factor in the box. A value of 1 maintains the original size. Value less than 1 decreases the size. Value greater than 1 increases. So if it's 1/2, I want to increase it by 2. New location. And we'll go ahead and accept. So it's been a while since I've done this. All right, so as mentioned, you get all of the dimensions. Are we going to get levels with it? Yes. All right, so if the levels come across, are they useful? Well, we have a table. If I have the print drawing in front of me that tells me what all these whole table items mean, then yeah, they could be pretty useful. So if they are on the correct levels. We'll get rid of the center marks, we'll get rid of the labels, and we'll just be able to see the part. Everything else, the title block, goes away. The alternate view, I'm not ready for it or I'm not doing anything with it, it goes away. So click, click, delete, click, click, delete. Did I get enough there? Delete, delete, and delete. Okay, so that gives me my base geometry with all of the other stuff intact. So I do want to see it. The level 0 is current. Oh, guess I don't need that one. And well, that's an interesting question. Did that come in as separate entities? No, it's seeing it as a full dimension single unit. Sometimes we'd want to watch out for any type of explode where that is 1, 2, 3, 4, 5, 6, 10, 15 just separate entities, and based on this, would have to go through and make the selection for each one. So I do want to move all of this at once. For our example, I'm not overly concerned with our position. So where this ended up, let's see, we're going to go back to, let's go into the transform, and we're going to move to origin. And if I can find that intersection, not enough information. So I'm going to escape out of that. It should have let me have the extension lines, but since it didn't, let's see under wireframe what we have to work with. So if I can get a point position and find its intersection, actually it'd be nice if it picked up the intersection. Okay, if that's the case, then I'm going to go with the standby of create a line. And since that line is going to be used on different level, let's go ahead and make it the center. And then endpoint to endpoint. Okay. So if I did all of that correctly, I now have an endpoint to pick from. Try the transform again. Move to origin. Finds that intersection. Now it's all going to jump. Should have just zoomed to fit and got it over with. Alright, so our shapes, we're going to go back into layer 0, turn off 3, 4, and 5. We're back to base geometry. Alright, the other thing was our dimension said, let's see, one of these was a quarter 20. So if I right click, I will get the analyze entity properties, and its diameter is 201. That means that scale worked correctly. If it wasn't, then I would have to go back into the transform, find my scale for sizing, and scale it correctly. Take the measurement versus what it was actually supposed to be and come up with a number. Alright, so once we verified that the scale is correct, we are in inches, so this was not a metric conversion. If it was a metric conversion, then we need to, and this is where the new interface is going to trip me up. We need to go find, oh no, it was over here under the configuration. We would go into the configuration, pick the metric, or go from metric to English conversion, and it would ask us if we wanted to scale in that process. Alright, so we successfully brought in our DWG. We've retained the labels, the center marks, the dimensions that we can use as reference. If I want to check something, I just turn it on. And if we clear the colors, that should put it back a little more visible. All right, so getting back into to that geometry. And again, we can rotate it over. We can go into quadrant. I'm not really concerned about the quadrant. We've done that enough times that you can pick where you want this to be located. All right, so going through the operations, we're still in mill. So we'll pick for the Haas and switch over to toolpaths. All right, so up to now we've just kind of gone in and we've started facing and contouring and pocketing and having all of those operations. But at what point do you make those selections? All right, so we're going to stay with our standard process under the files. Nothing really in here, just making sure that I've got the correct control, the correct items. Tool selection, program 1. And we can still assign the tool numbers sequentially. And then the stock setup, well, let's see, I don't remember the size. Let's see if we go bounding box and pick everything in selection. So it finds the corners and gives me a stock size based on those corners. 6.39 by 3.9. Well, I recognize the 3.9 anyway. Okay, so now we need a thickness, and we'll go with the 0.5 for our size. Accept. All right, so we have the display. We have stock size. Again, material may be a little bit over, and Alt-1 goes back to the top plane, setting it for normal. All right, so first operation, facing, is just to establish Z. If we're okay with the raw stock, understanding that it may have waves in it, may have scratches, scores, dents, dings, and otherwise as imperfections in the face, basically that facing operation is just to get this clean, make a nice, smooth, shiny surface. There are times where for cost, I may pick one side over the other. And in this case, knowing that this is probably going to be on a plate, again, held down with clamps, and we have to manipulate, I would maybe put a clamp in the corners, run the pockets, and hopefully my tooling plate will show up with some other clamp locations on the interior. And if not, then we're going to have a piece of 3/4 inch material, cut around, do all the geometry, and then flip it over and machine off the backside. All right, so again, that process is, what is our stock selection? What are we looking at in the way of material removal? And what are the capabilities of the machine? Envelope is a fairly small part, so envelope is not that big of a deal, but 7x4, borderline fitting in a vise. All right, so going down our list, our mental checklist of, does this make sense? And again, how many? 1. All right, we're gonna go kind of slow, take our time, get one piece out, and worry about it later. All right, if it's 100, I'm a little more concerned. If it's 1,000 or 10,000, we're going to be here for a while, and I need every second that I can get out of this. Looking at the part, first question you should ask is, does this need to be a square corner? Round tools do not cut square corners. I have to set this up as a secondary operation to come in from that side. That's an additional cost. That's an additional time for quoting this part. Hopefully by the time it gets to me as the programmer, as the setup, or as the operator, we've already made those decisions. Had a meeting, we looked at this, and everybody agreed this is the material we're going to buy. And it's either going to be pre-saw cut for it, or we're going to saw cut it at some length. We know what those dimensions are and how it's going to fit in the machine. All right, so, but in that first 30 seconds, we've made about a dozen decisions, and they all impact where we're going with this part and with every part. All right, so facing operation, if we need it, is going to be our first group. And are we going with the large face end mill, one of the smaller end mills running back and forth? And the issue is do I have one? Do I have a large enough facing mill to take this in one pass, so a 4 or 5 inch wide? Well, probably not. But a 2 inch, maybe a 3 inch is probably approachable. So we'll go ahead and say, give this a name. And we need to either pick the area that we want to machine, or our pop-up says define stock. Well, we define the stock by that bounding box and have the outside. I don't need to do anything else except let it use that bounding box. Let it use my stock. How do I want to run this as a facing operation back and forth? There may be times where I'd want to run this as a pocket. I mentioned the the cabinets and the wood, and there's sometimes that with materials, woods, plastics that have a tendency to chip out or splinter, that you would want to not face, because every time it runs off the end, you're at risk of doing something bad to the material. I would rather have a facing operation be treated more as a pocket, start at the outside and work its way in, and hopefully the last little nub that gets kicked off in one of the pockets, so if it does break out or chip, that it does it someplace that's going to be removed anyway. All right, so on the facing operation, the assumption is that we're just going to go in one direction or work back and forth to clean up. Obviously, if I have a 5 inch fly cutter or larger, if I can take that in one pass and get a smooth finish, that's going to be my best bet. Most of the time, we're going to have a 2, maybe a 3 inch multi insert facing cutter. So we'll stay with the facing. All right, so I got to this point. I'm looking at my my library and it's empty. So what we needed to do, well, I didn't pre-select the tool. I really want my my library in there, so I'm going to kick this out. Found something anyway. It assigned its own tool. And back into the tool manager should give me the split, the dual items. So when I open up my Haas aluminum, find those, I do have a conflict with one. So if it'll let me grab that, I can manipulate this to make sure I'm in the right one and make this tool number 10 so it doesn't disrupt, since I didn't do this first, and grab all of these items and move them up. All right, so this is the current tool list. This is the tool library that we pulled off the hard drive. All right, so the 2 inch face mill, not great, not bad, but we already have a 3 inch in there, so I can change over to it. All right, and then when we need the drills, we're going to have to go back, and since I wasn't paying attention to what I loaded, oh, there we go. Let's go mill inch, and that'll bring back in the rest of the tools. All right, so go ahead and accept. And when I get back into the parameters, then now I have my tool list, and I'm over to selecting for the 3 inch face mill. Can verify its diameter, that it's got the tool name, that the tool length and diameter offsets all updated accordingly. If that tool has the correct feeds and speeds, 50 is a little fast. All right, so probably not going to stay with that one. That would be one I'd want to change in the library so that it comes in with those numbers. All right, so if we go 800 on the surface feet per minute, and instead of 23, maybe 2, and get rid of the extra decimals because they're just there. That would be a good starting point. We look at what the results are. Do we get a nice clean finish? Is it tearing? Is it gouging? Is it or is it giving us the desired result? So face operation, staying with the parameters. Again, is it a new machine where everything's pretty tight and it can go in both directions and minimal amount of crossover? Or do I need to lift up and load the ball screws in one direction so that we're minimizing the amount of mismatch, changing the backlash, even though there's compensation, all that other stuff built into it. And it could only be a couple of tenths of a thousandth, but it's there. All right, so one way or zigzag. Each of the parameters, a cross overlap, I always have to stop and think about these. All right, so a cross overlap is, let's see, make sure I got my terminology straight because, like I said, stop and think about it. Is going to be the how much overhang on the side, so 25%. The along is going 110% past. The approach distance is minimum 50%, otherwise you're coming down in stock, which makes sense. And the exit distance is, as it leads off, at least a half an inch so that you completely clear the part before it starts to retract. All right, if I made this smaller, if this was 0, I could still be turning on this edge and it could lift off, but I would have a swirl mark there where the tool stopped. Possibly drug a couple more chips around with it, did a little washing machine at the bottom, and then did retract. That affects my finish. If I need the cycle time and I can stand to have that little bit of mismatch because we're going to have some other finish operation and it's not going to be as critical, we need a nice smooth clean surface, but it doesn't have to be mirror finish. I can get away with some of those time saving items. All right, so these are affecting how we're getting into the part, how much overhang, how much pass, and then I'm still not clear on the why I need an even number of passes, as long as I have enough passes to clean up all of the material. Even number of passes would force, if 3 would be enough, even number of passes would force a fourth. All right, so. Auto angle.
It would compress the overlap, right?
Yeah, it would bring everything down a little snugger, but it would still try to, and sometimes it would take it right on the edge to where it was, what exactly are you cutting? All right, so I haven't encountered where I've had to use that or good reason to use it. So we're looking at the approach, since this is coming out on the one way was our previous, coming across, lifting up, coming back. This distance is our approach, and how much it is, basically our 3-inch cutter overhanging the part at that 25%. That's what we're seeing as, as where it's determining where this first one starts and this last one ends.
Don't you want to do that if you wanted to avoid, especially like aluminum, where if you're doing a conventional, it's going to leave a lot of over swage, or what do you call it?
The swirl. So on the facing operation, not so much. So the swarf and the deposition of material climb conventional is more when you're getting into deeper and you're on a peripheral cut, not so much on the face. So usually the facing operation is going to be between like 5 and 10 thousandths. I want to take a minimal amount of material, get this as clean as possible, and have plenty that when I flip it over and remove it, unless it's just a lot of material, that I'm going to have to, remove a disproportionate amount on the backside. I'm going to go ahead and let it take a skin pass on one side, rough pass on the other side, and then go back to the skin pass if I need to. All right, so those are still going through the what is my material condition. And as I'm thinking through that process, I'm just making these decisions. And then I write the program, I get out the machine, and I go, yeah, I just thought of a better way to do that. It's part of the evolution and the iterations that you're going through. And it just comes from the experience of setting up a bunch of parts, making a bunch of mistakes, and getting through it. All right, so we changed over to zigzag. We kind of figured out max, so the one I didn't do was max step over. If I reduce that down, it's going to tighten up this gap. And then cutter around corners, well, we're not really doing corners. Stock to leave on floors, none. And move between cuts. If we do feed rate between cuts, we can switch it over to the loops instead of changing directions and coming back. Linear, or it would rapid. I have used rapid and it worked very well, except that when I didn't leave enough lead out, and it rapided through about a 1/4 inch of chromoly, 4130 chromoly, and made an interesting sound while it was doing it before the tool broke. All right, so as long as you have enough exit distance and the long overlap to get clear of the part so that it can rapid to that next level, maybe. But really the tool has to be very say almost 100% engaged for that to be a major concern. But again, it's a concern. So let's see if we loop, and maybe I do the high-speed loop and feed it up to from our 8 to 30. Still significantly faster, but not a rapid. All right, so juggling numbers to see where we can get to. Depth cuts, no. Linking parameters. We have enough clearance if they're. I'm going to stay with the absolutes. The clearance is I'm taking 10,000ths off of the material. If I was taking, I said if we had a piece of 3/4 inch stock, I have a 1/4 inch on the back. This retract plane is where it's going to rapid to. We're rapiding right to the top of the stock. What the remaining stock on the backside if we're cutting that face. That's a little too close. Right? So, and then the feed plane, want to make sure that it's coming in slow enough that if it is engaging in the part that there's a little bit of mismatch, the part's overhanging, that I'm still going in at a rate that it can make that cut and survive. So let's go to, well, we're only taking 10,000ths here, but we'll go to the standard numbers, 1, and then feed plane at 0.2, top of stock is 0, depth is 0, right? Because we're right there. We just want to see Z0 as the cut. So, and then we'll go ahead and accept and see what it looks like. All right, so dirty operation has the X over the toolpath, and that is that I accepted it. It generated a toolpath. It was there, and now I've made changes. The dirty toolpath is to regenerate. Now I have my loops. Now I have my approach and my exit. That looks like what I want it to do. 4-inch wide with a 3-inch cutter. I can maybe get away with 2 passes. So if it will go up and back, then on the cut parameters, we're going to be looking at the max step over. Let's see if it'll go to 100% and regenerate the dirty operation. Right? What I run the risk of there is that I have left a razor thin or a thin razor blade all the way down the center of the part. If my insert cutter has a little bit of back angle release, has a little bit of chamfer on it, has or whatever. So 100% is probably not a good idea. Maybe 90, if I can still get the same result. And each time we're regenerating the dirty toolpath. Yes?
That's when your boss tells you to grind those down.
Yes, to grind them off, yeah. All right, so I've gone from 3 passes at 8 inches a minute. That's more than 8 inches. So I've gone from, potentially 3 minutes to 2 minutes. All right, so I've saved a third of my time. It's a good start. All right, if I have multiple inserts, then obviously I can feed faster. I don't want to get too aggressive on the first part. Again, the goal is to get out to the machine, get making parts, and if it's 1, I'll eat the minute. If it's 100, I'm going to get these into production, and then I'm going to start looking for another minute here, another 30 seconds, another 5 seconds, another, however far we get to. All right. So facing operation done. We're going to hide the display. All right. So everything else is, aside from the pockets, is drilling operation.
Is there I'm sorry. Is there an option on that display to show the the size of the cutters that's moving them down?
More so on the simulations. I think it's more of a visual thing that we're just, the tool is about this size, the part's about this size in relation to a tool that's about this size, and I expected to see this. So the two, we've been doing a lot of the full. If we do the back plot, and let's slow down the back plot.
Right.
Yeah, there we go. Thank you. Right in the middle, right in front of me, where it should be. Okay, a little bit faster than that. Not as fast as that. That's probably our best, quickest representation of the single tool. All right, so it speeds up a little bit, goes through the rest of the way.
It would be cool to see what the overlap pattern looks like.
Some programs do, and it just depends on clutter. I haven't looked for it, and there may be a place to turn it on for the tool view. Typically, what you end up with though is when it is on I think ProCam did it, is you end up with a circle out here. You end up with lines of a certain color with the line that is actually the tool path, and then the arc, and then arcs as it goes through, additional circles, and it gets kind of busy. So where do you want the trade-off of, yeah, it'd be nice, but if I can see it in the simulation and know that there's enough overlap, I don't know that I need to have all of those individual tool size locations at each of the endpoints of the tool path.
It'd be a beginner's curiosity.
Yeah.
By the time you're experienced, you don't care.
Yeah.
You know what it is.
You have your best guess. Knowing and guessing are two different things. All right, so initially I said we were going to stay with a 1/2 inch stock, put this on one of our little tooling plates, clamp it in a couple of positions, do all of the interior geometry, and then we would be able to change the clamps to the interior, run around the outside. All right, so that's a specific of the part. There's nothing that says that I have to go that way. If the machine shop manager ordered me 3/4 inch material and said, hey, you're putting this in the vise, then my job is to figure out how much torque I need to put on that vise to not bend this 4-inch piece of 3/4 inch material. Because if I go right to 90 foot-pounds, I bend it. I put a bow in it, and it may not be much, but it's not flat. Right? So the last couple pieces that I ran that had to be flat, I haven't measured, but when I put them down on the surface plate, I got that little bit of air suction that told me they were pretty darn flat. I had 10 foot-pounds on the vise. And I did not push anything harder than about 20 inches a minute. And it left a nice, pretty finish. I think I pulled up the video or the picture video off of my cell phone, and it had that nice, pattern mirror, but it took a little bit longer than just plowing through it. All right, so in that case, then we're going to go to the pockets. The pockets on the interior. In this case, when I did this video, I said I wanted my truncated Mickey Mouse ears, my overruns. A lot of times designers will just put a drill point into that corner, you feed up to it, you run into it, and you come out. The issue there is that sometimes the tool still tries to get into it, and we've still removed a lot of material. All right, so in this case, this is basically a line over the corner, and we have about 10 to 20 thousandths of clearance from that square corner contacting that arc. All right, so square to square. So advantage here is that I'm going to be able to pretty much take my 1/4 inch end mill and run it pretty tight into that corner, at least on the pocket, and the finish will be able to get in, clean it out, and get it clear. The slot, we'll try the slot operation since it kind of ramps in a little bit different, but if I don't change tools, then I haven't really gained much. So I think this was about 2 inches wide, and this is an inch or 3/4 inch. That says that if we're going for production, I probably need to drop the 1/2 inch end mill in there first, come back with 1/4 inch, and finish this one with the 1/2 inch. All right, so again, just making decisions as we go. All right, so that being the case, let's try it for the pocket or the ob round, and that will be Pocket operation, select the pocket chain. So pick an edge. Pockets are naturally interior. You don't have, unless it's an open pocket with an island, it's going to look for the interior. As soon as we select the second pocket chain, that gives it a little bit more information to say that there is an island or something that we need to avoid. All right, so we haven't had that situation where we've had to select the second chain. So if I go for the slot mill, that is going to give it, different methodology. So ramping in, stepping out, cleaning up on the finish pass. Pocket, on the other hand, is, in this case, is more of a lace. And, well, I say the default is the lace, but when we go into the, the cut parameters, it gives us the other options. Slot mill doesn't quite give us those options. All right, so I'm going to go back and find for the 1/2 inch, and we will call it slot until otherwise. Going to stay with the numbers, maybe a little adjustment, but I will survive. Compensation, we'll go ahead and pick for wear. Entry exit arc sweep. All right, so as this is coming in, 180 degrees. And what do we have? Perpendicular entry. Well, we have enough step over and no material leave on walls. We're going to include the rough finish or the finish in this operation. We can always go back if I don't have enough control or there's something specific that I want to have happen. I can always create a second contour operation as opposed to putting the finish embedded in this slot. All right, so the rough finish, plunge angle. All right, so how it's going to work around. 3 is going to take a little while. All right, and on that length, so we'll probably want to go. Let's try 20. See how aggressive 20 is. Probably don't want to go 45 because that's in and done. Step over amount for the roughing is 1/4 inch. 1 finish pass, and we'll drop the spacing to 10 thousandths. All right, the less material that I put on the wall, the more chance that I'm going to have that clean surface and be able to put it on size. Downside is that is a critical tolerance. We want that slot to be pretty tight on plus or minus 1/1000th or something. I don't have a secondary operation. I would have to start back at the 1/2 inch tool, run completely through the slot operation to do the finish again, take the measurement. Oh, it's off a little bit. I need to take a little bit more, put a little bit more into compensation. I have to rerun the whole operation again. So a reason that I would put a separate contour is that I want to be able to stop the machine in there, or at least tell it to pick up be able to pick up that tool mid-program and go in and clean up that slot as a separate operation. Now depths, maybe a little bit of breakthrough if we want to do go into the sacrificial plate a little bit, our universal tooling plate. Linking parameters, same things that we're doing, absolute. All right, so I can stay pretty close. The first time through, 1/4 inch is a little bit disturbing watching this thing rapid to a 1/4 inch above the part. So at least on the initial, I'm going to stay 1 inch. I'm comfortable with 100 thousandths. What you observe at the machine is it's rapiding, and then there's just a microsecond of a pause, but it's perceptible. You can see it or sense it or whatever. It happens. That it does the deceleration at 1 inch, and it's slowing up a little, just enough that looks like 1 inch or it doesn't. And then as you are approaching the point 1, you hit the feed hold on your setup or your first go arounds, and then that looks like 100 thousandths. Okay, go ahead and make the cut. Top of the stock is still 0, and again, if we were plunging into that slot, then we would start doing incremental on these values to change where the rapid actually stops. All right, so stay in absolute until you get a good comfort level with what you're telling it to do. All right, when we have a need to get to that next level, get there a little bit faster as opposed to feeding, then we'll use the incrementals.
I'm sorry, if you've got, in this case, a pocket, and you're going to do it in
one step.
You're going to do this in one step?
Half inch with a half inch tool. It's going to be a little aggressive, but yeah.
Okay, so if on the other hand you were going to do multiple steps, because you've selected absolute, is it going to retract and all three steps going to retract back up?
Yes.
And
above to the feed plane, they will retract to the 0.1 to the feed plane, move back to the start position, make the next engagement to the next level.
So the only difference between the tool path of the different steps is how deep it's cutting.
Right.
If you put that to incremental, then would it shift the entire operation down with each step? Or doesn't it drag all the way up?
The feed plane at incremental, and we have to, again, kind of work through the logic and find the right combination. If I tell it that the feed plane is incremental, then it should go, if our first cut is 200 thousandths, the next rapid should be to minus 0.1. And then our next feed plane is minus 0.3. Our next rapid should be to minus 0.2. I know I'm throwing numbers out there, but
I understand.
But you're rapiding to that next level.
Okay.
If that cut hasn't been made and it's not there, you're rapiding into the part.
Sure.
So first time through, no. As we're looking for those seconds and milliseconds over the 10,000 piece run, yeah, I will get more aggressive and I will get more comfortable. That whole conceptual, I'm seeing it run, I'm confident the machine can handle it. Let's go ahead and make those choices. All right, so we'll see what it does. All right, so ramp in. Even at 20 degrees, this did a in and out, and that is too aggressive. I want to see it come around probably 2 times to get into that geometry. So the cut parameters, let's see, where was that rough finish? So back it off to 10 degrees. And the step over, maybe we'll go down to 0.1. So it takes a couple side passes because full width, full depth, and then half radial engagement. At least not on the first part. So we get in, that's still going to make a little bit of noise. And once it's there, it makes one pass, and only this first, only this first portion would be almost full width, full depth. After it gets into the ramp and the engagement, it's going to be less material, less material, less material, steps over, less material. Issue would be that it does this 90-degree turn. So on the simulation, I would want to see, well, the ramp in is basically at the finish. So either this, let's see, so out, in, out. So we told it 180 degrees. Let's go see what it does. Drop it down to 90, see what kind of difference that makes in the lead in on that edge. All right, so it gets to, okay, that's a little more clear, is that as it comes back around, it makes a loop, picks up the next edge. I'm okay with that. And then the 90 degree is more of an angle in. Let's see, we get to that point, it moves back to where it can start the lead in, and the lead in picks up and goes to the wall. All right, so I'm good with that. The 180 degrees and that line being vertical, that almost looked like a straight plunge into the wall, which is going to leave a parting witness mark up against that edge.
Rotate that. Okay, that straight line is actually horizontal. 45 degree looking line.
Yeah, it's lying in the.
In the plane.
Yeah. So. All right. So again, part of it's being able to decipher, figure out what all those colors, lines, arcs, getting all that geometry to make some sense. All right, so to duplicate or to produce fresh. Slot probably isn't going to apply to this one, so produce fresh. If it was very similar geometry, then I would consider going to just copy the geometry and make a duplicate slot pocket. That doesn't mean that we can't try though. So copy, paste, and being able to back out of the parameters says that on the toolpath type, let's jump back to pocket. Everything's set up with the tool. I'm still in the 1/2" tool. What cutting parameters will I retain? Probably not a lot. It did change significantly. What I would be hoping for is that my linking parameters, well, I got I just kind of reverted back, which is going to be the safest. All right, if I see those as numbers that I didn't enter, I'm more likely to pick them up and do something with them other than being close. All right, so parallel spiral, maybe zigzag. Problem with zigzag is that it will typically leave little scallops, and if we're coming back with a 1/4" tool to clean up the edges, it's heavy, light, heavy, light, heavy, light as it goes through whichever direction the zigzag picked up. One way, going up and over, no. So just kind of comparing those two. Constant overlap and spiral has a little bit of a step. Parallel spiral is that hard turn into the next level. So if we can morph spiral, or I don't know about the clean corners because I think that one is the one that does the loop. Probably we'll try the morph spiral or the constant overlap spiral. Getting those engaged, and then you'll pick out one that's your favorite. The true spiral, that basically starting at the center and moving out. Each of those spirals is going to generate a point. It's not going to be a GO3. It's going to be XY, 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 and this will probably, even on this side, generate 1,000 lines of code. Something along those lines. It will be flying across because it'll be very small increments of movement. We haven't done much in the way of the tercoidial. Tercoidial is that different monster, that high speed getting in, making smaller cuts, but going very fast. Is it worthwhile on the first go around? Probably not. If we can make something of it, then we'll give it a shot. So let's try the morph spiral first. Tercoidial cuts gets turned off. Step over percentage at 50. I'm going to stay with the 0.1s if we're going to bury this. If we're going to be the 1/2" engagement, then I want the radial engagement to not be as deep as the axial. If I vary it, if I don't go as deep axially, I can go a little deeper radially. All right, and we want to. And the issue is not so much tool loading as clearing the chip, getting the coolant to the tip. The lubrication, the heat, all of that is our consideration. Entry motion goes from, I have enough room, I'm going to stay with the ramp. And clearances were okay. I still want to be kind of aggressive with the 10. It is kind of annoying the first time you run a 1 degree or a 3 degree and it sits there for 5 minutes going zzz, or the helix at 1 degree is sitting there making 1,000 loops to get to a 1/2" deep, and you're wondering why did that take two minutes to get engaged in the part, right? But that's an observation that you make at the machine and come back and make the adjustment after the fact. Let's see. So lengths, minimum, maximum lengths are the tool. Percentages. Clearance for the starting point, how far above the part, XY clearance for the walls, and then we just set the angles, kind of my habit just to jump right to the angles. Auto angle, 0 degrees, doesn't really matter on this one. If we were aligning to something, we could pick a better angle or see what it generated on the auto. Aligning the ramp with the entry point and ramp from entry point. Well, we have to set an entry point. Finishing, same thing. We have 10 thousandths, one pass, only at final depth. Well, we're only cutting, but if we decide to come back and make depth cuts, that would be probably something I would overlook, and I would be wondering why is it finishing at each depth that I'm making. Start finish at close vicinity, and don't really need to do a retract. There's no islands, there's no nothing on the interior to run into, so we'll stay with that. Lead in and out, probably not that large. All right, so lead ins and lead outs are how much room you have to work with, and again, it's kind of the closer to the better. I don't want to really hear it buzzing material as it's down feeding, but I also don't want a huge amount of cutting air. The other issue would be the consideration that if you are in that, I think what it's called, the not the reverse where the one where you enter the value is the tool diameter, the control. Okay, it's back up here. No. So the control or the reverse where you're having to enter the value of the tool diameter, then the rule is that you need to have a little more than the radius. You need to let the control have that much movement to be able to calculate the compensation. When our tool is basically defined as 0, it doesn't matter. I can be as close as I want as long as I'm not plunging in material. So if this was a very narrow slot, I could go 10 thousandths. And the arc could be maybe 30 thousandths. All right, do I need to come in that close? Probably not. But I can buzz it that tight. All right, and then the sweep, 45 degrees. The ramp heights, those get a little bit different. It's coming in at a little bit of an angle, making the approach, and coming down on this line. The arc and the helix height is kind of the same thing. The combination of those two will kind of set the movement in X or Y and Z at the same time. All right, and then whatever we've set over here, we're going to populate over to the exit. All right, so internal to this pocket, I have no extensions, which makes sense. I don't want to extend this. All right, so it's eliminated out of this group. And we've pretty much ignored the use entry point, enter on first depth cut only, plunge after first move, override feed rate. Very specific items that you want to have happen for a very specific reason. So most of the time these aren't really applying unless you see something that you want to have it do. Let's go ahead and apply those. Depth cuts. So we said we weren't going to do depth cuts. Maybe I'll bring the pocket through 5 thousandths. And the check for this is if I go negative, gives me the value 0 to whatever, you can't put it in negative. All right, it's going in that direction, it's continuing in that direction, it's a positive value. And then same things, we're going to go back to absolutes. Now we'll go ahead and do 1, and then this is all interior to the part, but I mentioned clamps. As soon as you engage clamps, that retract plane becomes a lot more important. Feeding between same geometries on the same operation becomes much more important. All right. As long as we can clear clamps, or we're moving around inside of the part where it's not going to be an issue, as soon as we take a jump over where there's going to be a clamp, that value has to go up. All right, hitting clamps is never a good time. All right, so did it add the 505 for me, or was I not paying attention? All right, So again, we copied. We had an existing operation. That existing operation didn't know quite what to do. So we're going to regenerate. Oh, guess what I didn't do? Pick new geometry.
Yeah.
All right, so two ways to get into the geometries. We can go back into the parameters, pick the chain geometry. If I just want to update the geometry, that's going to be fun. Then we're going to remove that chain, delete. Then I have to add a new chain. It's going to find its way all the way around. And again, I'm not concerned here with the directions. It made another change, so it has to regenerate the operation, and there's our morph spiral. All right, so that finish pass doesn't get into the corners, didn't need it. Okay, so back into the parameters, go to the finish, turn that off because I'm going to change tools. I have to have a separate contour. All right, and then that turns off the lead in, lead out, another regenerate. Okay, so that finish pass now, that was
on the inside of the spiral pal.
So that finish pass that left 10,000ths doesn't leave 10,000ths anymore. Cut parameters, I now have to go back to the stock to leave on walls and say I want material to clean up on the wall. So leave the 10,000ths for the 1/4 inch tool. And then because that 1/2 inch tool is barely able to get in that corner or not, that 1/4 inch tool is going to have to take the full engagement into that corner. So let's see. Let's go ahead and regenerate that. And then mill tool pass, we're going for the contour. Contour could be part, and we would go to partial. And usually when I use partial, I go ahead and tell it to wait. Let me do all of the selections. When we're doing the chain, whatever I pick, that's going to be the start. And then I do want to make sure that my direction and my side to cut are correct. So I'm always the one going, if the end mill is spinning this way, moving in that direction, I'm on the right side, I'm in climb, that's good. Otherwise, I'm changing directions, changing the sides of the arrows. So we have a 1/4 inch tool set up, and go ahead and I'm jumping over the speeds and feeds. Oh, and I meant to hit the plus instead of the accept. So since we're here, let's go ahead and look at the corners. This is going to be a pretty heavy engagement. So where did we get to? Okay, so I jump over. We're going to just accept the defaults on the items. We'll go into where so that this is the finish pass. This will be able to hold the tolerance. And then let's see, depth cuts. We're still going to treat it as the full depth. Maybe we go with multi-passes, going to depth, stepping into the wall a couple times so that it gets into that corner and is not taking that full heavy engagement on the last pass. So lead-ins, we had our same numbers, and we'll be able to see a little bit closer. All right, so I left 10,000ths of material, and at the 45 degrees, that's going to be pretty close. Now I have the adjust start of contour and end of contour, but I'm still in a pocket. So on the exterior, I can do these. On the interior, I want some type of arc lead in or lead in into the wall that actually will give me my geometry. If the material, how do I put that? If the loading and unloading of the tool deflection, I may want to consider overlap. Right, so as it comes back around to the starting point, there is a significant enough overlap that the tool gets to unload completely before it does the retract. Let's see, breakthroughs. Let's go ahead and stay with the same number. And multi-passes. Well, since this is a finish pass, I want 2 finish passes at 10,000ths. All right, so no roughs. All right, so I can manipulate that however I want. The difference is that we're basically dividing this up as this is going to be heavy, these are going to be lighter, and I can see my heavy cuts in relation to my lighter cuts. Since both of these are going to be technically light cuts, I'm just going to treat them as finishes. All right, and we only left a little bit of material. It's those corners that I'm concerned about. And then the linking parameters. And we'll go ahead and accept and regenerate 30 toolpaths. All right, so first 10 thousandths pass, slightly lighter. Second one, heavier, goes completely into the corner. All right, so until I see what the survivability of that tool is going full into the corner, I'm going to take that second pass. All right, so drill points. Oh, and there was one that I missed on the center, so I can either put it back on the other level, or I'm really not concerned about my center marks. So I'm going to go ahead and make that go away. All right, so I want to get to the outside contours. So center drill and tap. Let's just go with the drill and tap. Okay, drill and tap and the drill and countersink. The other ones, we would just load up the drill and tell it to peck the holes through. And so the drill and tap, we set up for the drill and pick the points. And if we set for the mask, a lot of times it's just going to be easier to find those centers. If there's not a bunch of them. If there was a bunch of them, like a whole bunch of them, then we would go over, set for the diameter, and have the software find the centers of those holes, but we would have to do a pretty good job of verifying that it found the correct sizes and there weren't any anomalies.
For the fifth one, it's identical to those four.
Okay. All right, so drill, no tool. So we're back into the library tools. It defaulted to an 1/8 inch drill. That was nice of it, but not anything that I can use. These are really the small ones, so I think we can get there quicker than setting the filter. So, oh, we're at 2 decimal places, so we know it's a number 7 drill. It adds it in sequence, and for aluminum, we would be at 200 surface feet, 3,800, and about 5. That's a little on the heavy side. We'd like it. 30 is still pretty aggressive, but if we manage the pecs, that would be okay.
Graham, this seems like a little bit late in the semester to ask this question. Surface feet per minute is the parameters that you want to begin with, and it suggests feet per minute and your feet, your speed and feet, and then you go in and manually say, yeah, but let's tune it in a little better.
Right. So we're starting with that chart that said aluminum can run at 200 surface feet per minute, steel at 100. Exactly. So we're starting with that. When it comes down to, we go to a carbide times 3 to 5. If we are reaming, that gives us another set of parameters. So we're juggling those numbers. What I really like to see on these adjustments, one of the adjustments that I'm making is on this feed rate. I don't need this feed rate out to 3 decimal places. It's not doing anything for me. So if I see a nice feed rate and coming across on the screen, that's something that I can manage. And if I have to change it, then I'll go F20, or I'll do something at the control to adjust it.
I mean, my question was, you set the surface feet per minute, it sets feed and speed as a suggestion, and then you have the option.
No, it's calculating based on the tool diameter of 0.201. It's running into that D times the cutting speed divided by, cutting speed times 4 divided by the diameter. And so we're coming up with that value. So it's calculating that value based on a 0.2 diameter drill, and then the feed per tooth goes through the inch per minute calculations or revolution per minute calculation, depending on what we're telling it to do. and comes up with about 4 thousandths is 30. Well, exactly 4 thousandths was 30.4 or whatever the number was that I overread. So when I make that adjustment and say it's close, and I see a number that's still close to what the original was, 4 or 5, what I'm doing is basically saying, what, am I going to be able to stand there and watch that drill peck at 30 inches or 40 inches a minute when I would rather see it at 30 inches, and probably I'll end up slowing it down to 20 inches. So that's the juggling act right there of how bad is that drill going to squeak as it's getting through that material. At 40, it's going to be a pretty heavy squeak. At 30, it's still going to be pretty heavy, but probably manageable. At 20, whatever. All right, so, again, it's that observe and react thing of getting it out to the machine, getting it running, and saying, wow, that was really a bad guess and way too fast, or, oh, that was a bad guess and it was way too slow. But either way, I'm going to have the ability at the control to make another choice and get it sped up or slowed down, come back to the program and feed that into my toolbox that next time I see it, 30 was a little bit too fast.
I understand. But if you went right now, you changed the feed rate of the speed. If you went back over to the surface feed per minute and changed that to 150, it's gonna change the feed rate, isn't it?
Yeah.
Yeah.
Because it's going to update the calculation. But going slower also means that my inch per minute or my feed per tooth calculation changes the feed rate.
Again, setting this surface feed per minute gives you a suggestion of what the calculated feed ought to be, and then you can say, I like that. You're not going to put a feed rate in it and say, oh, that represents 147.6.
No, it's kind of giving you the choice. Do you want to put in the feed rate and the RPM, or do you want to put in the surface feed per minute and the feed per tooth and then adjust from there? It needs two of those pieces of information, whichever two you want to use, you pick, and then it calculates the other side of it. So if we want to completely ignore feed per tooth, we can put in our values and whatever it generates, it generates. So I wouldn't say it's a calculation. It's not really a suggestion. It's calculating the value for you. And if anything, you're making the suggestion that it's steel, it's aluminum. This is the surface feet per minute that I want to start with. And if you know the value of 2,800 and 15 inches per minute is where it ran optimum last time, I'm completely ignoring SFM and FPT. So nothing's set in stone that it has to be that way. And as the drill wears and gets a little dull, and we've cut the 1,000th hole with it, and it's time to sharpen, those are probably going to be too aggressive numbers anyway. All right, so drill counterbore is G83, straight peck or straight one in out, no peck. And the counterbore portion of it says that we're going to have a dwell for G82. Put in the dwell, then it gives it the P value and has it stop. So, if it was actual counterbore tool. Peck drill is our G83, 100 thousandths peck. Still pretty aggressive at those rates, but probably manageable. Chip brake is G73, high speed. It goes in, it retracts 5 thousandths, it goes in 100, it retracts 5 thousandths, or whatever's set in the control, but typically 5 thousandths. Just enough to break the chip and go to the next level. So never a full retract. Hard materials that want the tool to stay engaged, but we still want to eject the chip, we're going to keep that tool tip warm and cutting. All right, if it's something that we need to flush the chip out, it's the stringy trying to weld up chip, we need to flush it out, then we're going to do the full retract, let the coolant get in there and go back. Tapping G84, we're not there yet. And then the boring cycles G85 through G89, just depending on what grouping you're running with.
On a rig, in the CNC machine, you ring, you go in, you stop the ring and then retract.
Either way. I mean, it depends on material, finish, what the specification. Most of the time, it goes in. I tell it to go on a ream to feed in and feed out at the same rate. If it stops, it runs the risk of dragging the flutes up the face and leaving 6 little lines.
I thought a reamer makes the hole a very specific size,
It does.
so it shouldn't be straight.
It shouldn't. Doesn't mean it won't. All right, so if it's exactly on size and you've loaded it, and depending on tool holder, how much protrusion you have, tool deflection, any number of possibilities, it could drag. I would just soon have it.
Okay. Second question on the reamer: how far, if it's the hole is all the way through, how far does the reamer have to go past the bottom of the hole?
Technically, past the chamfer. The lead chamfer on the reamer should go past the hole. Depends on how much wear. If you've run that reamer, a couple hundred times and you're starting to get the little wear on the tip, probably needs to go a little further, or it's time to grind it, push it back a little bit, pick up fresh fluid. And so, you'll observe by putting the gauge pins in and saying, wow, that hole's not quite to the same tolerance as it was on part 1 at part 500. Then we start looking at the tool life, longevity of, we ran 200 parts. It's time to change that tool out because our go, no go, just no goat. Or just goat or whatever.
The reamer's oversizing the hole.
Yeah.
Undersizing.
Yeah, it would be, as it wears, it'd be undersized, yeah. All right, so same things, top of stock, depth, absolute, minus 0.5. So I like that number because I'll go over to the tip comp, have the tip comp calculate the depth and breakthrough amount of 10 thousandths. And again, if we're following this with the reamer, or we're going to try and tap all the way through, we have that tooling plate on the backside that we got to be concerned about. That's going to be a problem. All right, so are we going to get out the cordless drill and the tap, and while the next part is running, chase all those threads, or are we going to drill it deep enough that it can pick up the next hole? Or is our fixture custom enough that I can drill an oversized hole so that it has relief on the backside, that when that spiral point tap is pushing the chip ahead and I'm concerned about pack up, it has room to pack up.